Hello, in this video we're going to show you how to create a cube map, also known as a skybox. So what is a cube map? Cube map is a series of 6 individual textures or 6 sides that are mapped to a cube, and that's essentially it for a cube map. And they usually would have some sort of pattern to them in a way that they actually flow from one side to the other, and usually a skybox uses a form of a cube map, and a skybox essentially is, well, a cube map, but a massive cube. The player and the actual world itself is within that big cube, and when you look around, it looks like you've got this nice high resolution world, but you can never reach the edges of the cube because it's essentially infinitely far away from you. So if I open up a folder called Skybox where I've got some images, got a few different ones. I'm going to be using these TGA images. These are just different images when stitched together in a cube, and when we're inside the cube, it'll look like we are, well, looking in a 3D world. It's gonna look awesome. I will provide a link in the description to an awesome website that allows you to download skyboxes. You can go ahead and create your own. The theory behind creating skyboxes from, let's say, photographic images isn't that difficult to get your head around. Here's a few diagrams just explaining it. So you got these 6 different images which, when stitched together, would form, let's say, the inside of this building, and you would just map them accordingly. Here, this is the method we're going down, where there is 6 different images. You may see it like this, where it's just one image that consists of all 6 sides and it wraps around. This is also another way you can do it. Once you've implemented this, you can go on to implementing this one as an extra task. But this is just another way of looking at it. So this is what it looks from the inside, and this is what it looks from the outside, and the player will be directly in the center. So that's it for showing you the theory of cube mapping. Let's get to it. As usual, got to create some shaders. So I'm just going to go to the Finder, duplicate these 2 files, and I'm going to call this Skybox. Call this one Skybox as well. And we're going to go to the skybox.vertex shader. What I'm going to do is just close that down so it's just easier for you to see. And let's have a look what we need to change in here. So we want a position. We don't want any texture coordinates. We want an output texture chord. It's going to be actual texture chords. It's going to be a vector 3. And for the matrices, we don't want a model, we just want a view and projection. We don't want to actually be affecting its position. So we got GL position equals projection times by view times by vec4 position 1.0f. That looks all good apart from the fact that I'm timesing model, so I can get rid of that. And text chord needs to become position, like so, and yeah, that is it. We are actually ready to get going. Actually, there's one thing I'm actually going to do. Actually, what we need to do is put a vec4 here and a pause. I'm going to assign this to this right here, and the value we'll assign to gl_position is going to be pos.x, y, and w. We don't have a z value, so save that. And now what we want to do is go to the fragment shader, close that so it's easier to see, and in the fragment shader it's going to be very simple stuff. We can get rid of the color. We want the input as text chords because that's what we sent out from the vertex shader. And for the output, we want color, that's all good. And for the sampler, we want something called a skybox, so that's what we're calling it. And we don't want sampler 2D, we want something called sampler cube, which is used for skyboxes. So now color equals texture skybox and it's going to be text chords. Apart from that, it's all good to go. So now what we can do is go to the main.cpp file. In the main.cpp file, there are a few changes we need to make. Not many, so it shouldn't take very long at all. First of all, we need to create a new shader object, and I'm going to call this Skybox shader. So I need to rename this to skybox.vs and this to skybox.frag. We're going to need some more vertices for the skybox. Luckily, I've already created them in Sublime. So if I go back to Xcode, the reason I've done this is just a simple cube instead of manually typing this out, which you've already seen before and you're probably already familiar with this. It's just easier to copy and paste it. You can easily get it from our GitHub page, and there will be a link in the description to that. So once you've got the Skybox vertices all set up, you will need to create a vertex array object and vertex buffer object for the Skybox. So let's get down to doing that right now. So what we're going to do is gl uint skybox vao skybox vbo semicolon, and do gl gen vertex arrays, and the vertex arrays is just going to take the parameter of 1 and then a skybox vertex array object. So skybox vao. Now we're going to generate the buffers into the skybox vertex buffer object. So gl gen buffers, one skybox vbo. Now we're going to do gl bind vertex array, and this is going to be skybox vao. I'm going to do gl bind vertex array. Nope, already done that. Now we need to do gl bind buffer. So gl bind buffer g_array buffer, and now skybox vertex buffer object, very similar to what we've already done before in the previous tutorials. So all of this should be very well familiar. GL buffer data now, and this, the first parameter you would take is gl_array buffer, and the size of the skybox vertices array, skybox vertices array. Now you need to actually pass in skybox vertices, and finally we're going to set it to g_static draw. Static draw just meaning it's not going to change at all. There's 3 different types of draw. This one is good for stuff that's not really going to be changing. So now we're going to do gl enable vertex array, vertex attribute array. I'm going to set this to 0. Now gl vertex attribute pointer. Okay, what part of it? It's not picking it up. There should be 2 T's in attribute, so attribute pointer, and this is going to take 0 and 3. Again, this is all very self-explanatory because we've already covered all of this stuff before, just typical stuff. There's 3 pieces of information. We're just getting size of the data type, which is going to be GL float. And now we just do GL void 0. And that's it. So that is fantastic. So it's moaning about something now. What's it moaning about? we have 5, but we expect 6. So we've got 0, 3, GL float, and there should also be GL underscore false as well. So now we actually load the textures, but I'm not particularly happy with the way we're loading the textures. Not the code itself, that's fine, we're going to be using this code. It's just we're having to rewrite this every single time, especially if we want to do multiple objects. We don't want to have to rewrite it every single time. So what we're going to do is create a texture file, and we'll just have a method for loading the textures, and also a separate method for loading cube textures as well. So let's just get down to that. First of all, I'm just going to go to the Finder, and I'm going to duplicate the shader file, rename that texture.h, add that to our project. And now in texture.h, first of all, we need to, let's get rid of all of this. I'm actually going to put a hash pragma once instead of the hash if guards. Need to rename this to texture loading. Texture loading. And this is just going to consist of a bunch of static methods. So first of all, let's just get rid of this. All the code inside here can go. Also want to get rid of the hash endif. And now we just need to include some files and set up OpenGL. So to define GLEW underscore static. If you didn't statically link GLEW, then well, you don't need to put this line here. Hash include gl/glew.h hash include vector. So now in the public, the first method we're going to have is a static glu int load texture gl char asterisk path. Okay, so what we're going to do is go to our main.cpp file. I'm going to cut this. Actually, I'm going to cut quite a lot of it. I'm going to get rid of all of this. So if I cut that, put that into the texture load texture method, and let's have a look what we need to change. So we need a texture ID. I'm going to rename this to texture ID. We need width and height, that's fine. We need to generate the textures based on the texture ID. We are binding the textures, that's not a problem. First texture ID. We need to do set text. This looks all good to me. I'm just gonna have another quick look over it just to make sure that we're not missing anything, or we haven't got anything in here that we shouldn't have. Okay, one thing I've just noticed, this needs to actually say path instead of, well, just saying an explicit image. So path, that should be okay. So if we go to main.cpp, if we go to here, just do hash include texture.h, scroll down to where we have load textures, and in the load textures, this code will now be a lot simpler. So all we do is glu int cube texture equals texture loading load texture, and for the path we just specify res/images/container 2.png. We need to copy that because we need to replace it here because I renamed it texture to cube texture. Let's run it. Make sure we get, oh, we got a control reaches end of non-void function. Ah, I can't believe I did that. So we actually need to return the texture ID now. So return texture ID, put a semicolon, that would help. So if we run this now, build succeeded, and we still have a cube. This isn't the cube map at the moment, we were just sorting out the texturing, but this allows us to easily reuse texture loading. So now what we actually want to do is do essentially the same, but for cube mapping now. The code will be very similar, so what I'm going to do is copy and paste this, rename this to load cube map, and for this it's going to be a vector. It's going to be a constant of GL chars, because we don't have one path, remember, we're going to have 6 different paths, and this is just going to be called faces. So texture ID, that's looking all good to me. Let's have a look what we got. So the image, GL text image 2D, we actually need to put this in a loop. The reason we're going to put it in a loop is to be able to go over our 6 different images very easily. Again, we don't want to repeat code, that's the whole point of doing what we're doing now. I equals 0, very basic iteration here, faces.size, I++, okay, so actually we don't need to do GL generate bitmap. You generally, because it's so far away, you would generally just have one particular image that you would load, because you're not going nearer to it and further away from it. You just load the right sort of size image. So for the actual unsigned char, what I'm actually going to do is cut this, and I just want to put this up here where we declare the width and the height. So we need to just do image equals soil load. Instead of path, it's going to be faces I, the width and the height, soil load RGB. Instead of RGBA, we don't want any alpha, so it's just going to be RGB. For GL text image 2D, instead of GL texture 2D, it's going to be GL underscore texture underscore cube map underscore positive X, and so this just indicates which way, like front to back. So you can easily just experiment with this, and this should actually be plus I. So this loops over the different textures. 0 GL RGBA, width height 0 GL RGBA, RGB again, GL unsigned byte image, soil free image, and let's have a look. Okay, for the texture parameter, we need to change this a bit. Instead of doing GL texture 2D, we need to do GL underscore texture underscore cube map. Copy and paste that and replace any instance of GL texture 2D over here. Let's have a look. Texture ID, that's fine. Now for the texture, what we got? Texture min filter, linear texture mag filter is fine. And now for wrapping ST, we don't want repeat, we want GL underscore clamp to edge. And then finally, we have an ST value, we want a R value as well. Again, it's just not a simple 2D texture, we need 3 parameters. And I'm just loving a quick look. No, that's definitely not what I wanted. Copy that, paste that here, and I think we're actually done for the load Cubemap method. So if we go back to our main file, in our main file we can actually finish off what we were doing. So we had cube texture right here. So now what we need to do is have a cube map texture as well, and that will consist of vectors. So we're going to put vector, and the class is going to be const gl char asterisk faces semicolon faces dot pushback res / images / skybox /right.tga. So this will be the right side of the image. This order does matter, so you can't just willy-nilly put it in. If you download it from a website, you might need to rearrange it. They may have designed it in a different way, so it's not bottom might be the top one, or it might be a different one entirely. So just bear that in mind. If it doesn't quite look like the images are lined up, that's probably what it is. So back TGA and front TGA. Now we need to do glu int cube map texture, or you can call it whatever you want. This is going to equal to texture loading, load cube map faces, and now if we scroll down, what we need to actually do is, well, draw the skybox now, because if we just keep scrolling down, so after we've done all the model matrix stuff, we're going to do gl depth func, and in here we need to do gl underscore le equal, and this changes the depth function, so the depth test passes when values are equal to the depth buffer's content. Now we're going to do skybox shader.use. Now we're going to do view equals to glm matrix mat4. This is going to be glm : 3x3 matrix, and this is immediately going to be the camera dot get view matrix. Now we need to do gl uniform matrix for float values. Now we're going to do the gl get uniform location, all stuff that we've done before. And this is going to be shader skybox shader dot program. We're going to do view again. Make sure you use the correct names from your shader classes. One g underscore false glm value pointer view. Okay, so that is moaning about something. Let's have a look. Too many arguments to function core, expected to have 5. Oh, it's definitely got more than it bargained for. So what is the problem? The gl get uniform location should only have 2, whereas I bumped everything else in there as well. We need to do something very similar for the projection matrix as well. So if we change this to projection, copy and paste that into here. Now what we need to do is just do the skybox cube. So gl bind vertex array skybox vertex array object gl bind texture, and for the texture it's going to be gl underscore texture cube map, and it's going to be the cube map texture that we called the load cube map method and assigned to GL draw arrays. And for the mode, it's going to be GL underscore triangles. It's going to be 0 and 36. Again, this is just a cube, so it's very simple stuff. GL bind vertex array. Put that at 0 as we normally would, and we just need to set the GL depth func back, and that is going to be GL underscore less. So this just sets it back to default, and now we should be ready to run. So let's run this bad boy, see how many errors we get. We get 1. No viable conversion from vector, aka vector. Okay, let's have a look why this did not work, because it's saying no viable conversion available. So we got geochar asterisk. That does not look like it should cause a problem. And in here we have no viable conversion. Why is it saying that? Because this is a const geochar dot pushback. We've done load texture instead of load cube map. Duh. So let's run that now. That should be okay. Well, it succeeded. Let's have a look if it's running. So no, it is not running. So there's something wrong here. Something has gone terribly wrong. Let's have a look at what. So first of all, let's scroll down to here. Let's make sure that we are, make sure that we've got everything. So first of all, I'm going to comment this out. Okay, so the cube is a-okay. Something about this it doesn't like. So, as usual, let's just make sure we go over it and see if there's any problems. So gl.func edit equal shader box, Skybox shader use, camera.get view matrix, uniform matrix for float value, uniform location. Again, I'm just having a quick look myself just to make sure there is anything that I have not missed out. Then we have Skybox shader.program projection, 1 GL false value pointer projection, bind vertex array. We're binding the Skybox vertex array object, texture cube map. Okay. It is still, let me run it again. Did not have a look in here. So it's saying fragment compilation failed. Line 12. And I'm going to guess that's because of the fragment compilation, line 12. So what's wrong with that? We have the color, and that's equal to texture, Skybox text chords. I can't really see anything that stands out to me. The text chords should be a vec3. This is always a problem when you try and use existing code and you try and merge it. There we go, it's that one simple thing. We try and merge it with other code. There's something that you forget and it ends up breaking everything, but it still compiles. So we got this scene. And look, it literally does look like we've created a 3D world. If I look at this direction, and I click the back key, I'm moving away because we can see the cube getting smaller and smaller. but everything else is staying the same because we're going to be infinitely far away from all of the sides. And imagine if you have a bunch of objects here, and let's say this was just a load of C, and then you had sort of your own confined level, especially if you, own confined island that you was playing within, and especially if you can't get off the island, using some form of skybox is fantastic, because just look at the illusion of a 3D world that this simple skybox has given. Imagine trying to create all of this manually yourself. Actually, as you can see, I believe I've messed up the images. I think I've got them in the wrong order. You know what I'm going to do? I'm going to leave that to you. If you have in the right order, fantastic. If you don't, I want you to fix it. That should be a simple fix. You just need to just rotate these images, not in Photoshop or anything, just in the actual vector that you're putting them in. So you just need to just put them down one and just make sure they are all lined up. But apart from that, we have a cube mapping example all working with skyboxes. If you have any questions, feel free to post them on my education platform, sonarlearning.co.uk. There will be a link in the description. If you want to check out the source code, feel free. There will also be a link in the description to that. If you like the video, fantastic. Please give it a thumbs up, hit that subscribe button and leave us a comment. And as usual, thank you for watching, and I hope you have a great day.